Now, refrigerants are the working fluid in a refrigerating system. Its main function and release heat to the atmosphere. They are working fluid or representing medium itself. So its main and only function is we have to absorb the heat from during the refrigeration process and release the same heat to the atmosphere during condensation process. It recycles again, cycles again and again, and same refrigerants are used throughout the system. The cycle, not system. The circulation of refrigerant are done by the compressor. So, what he is doing here, it is absorbing heat from the temperature system and discards the heat to the higher temperature system. Absorbing from a lower or low temperature system and dissolving it to a higher temperature system itself. What are the, first of all, what are the refrigerants we have used at the beginning? First, we have used ice and mixture of ice and salt. Was the first refrigerant used in 19th century itself. Next, ammonia, sulfur dioxide, methyl chloride, carbon dioxide, all these refrigerants come into use. And they have used. Most of them are early refrigerant materials. Most of them are discarded now because we have better variants now at this moment in terms of safety measures or lack of chemical or thermal ability. Now, present days, many refrigerant includes halocarbon compounds. Hydrocarbon compounds are used for air conditioning and refrigeration systems. So, what we are using mostly are halocarbon, hydrocarbon compound are used for refrigerator system itself. Now, first of all, you have to know the suitability of a certain application is determined by its physical, thermodynamic, and chemical properties, and by various practical factors. There is no refrigerant which can be used all type of applications. As I have told you, there is no ideal refrigerant. It depends totally on physical properties. Achha. Next, I'll come to later. If one refrigerant has certain advantages, they also have certain disadvantages. They have to choose according to the advantages you need, and you have to add according to disadvantages which you don't need. So what are the desirable properties from an ideal refrigerant should be? We have the above properties. There is no ideal refrigerant. No ideal refrigerant is there. Refrigerant should have that ideal if all of the following properties present to it. It's low boiling and freezing point. Boiling point should not be very high, and freezing point should not be very high in the cell, because freezing point is supposed to be low in order to freeze the or absorb heat from atmosphere more or less near to the surrounding temperatures. And boiling point, if it's very high, very low, it will boil very quickly, and the transformation, the heat transfer from air very quickly, or maybe in a temperature much less than even the surrounding temperature. Thus, which will happen, it will even in the thermal temperature, it will boil, it is boiling heat, so you don't have to apply power. You don't have to run the compressor, and if you don't run the compressor, there will be no circulation of the fluid itself. At the same time, freezing point, if it is too low, then you have to, that's also a problem too. You should be near 0 degrees centigrade or so, or let's say 30 degree, 50 degree less and so, but not 100 degree or 200 degree, because at that moment you have to be cool the refrigerant to a very low temperature, which is inconvenient and more time consuming in one set. Next, high critical temperature and pressure. Critical temperature means critical temperature here, the transformation from liquid to gaseous state takes place without any absorption of latent heat. This creates some problem to you. Just 1 second. High critical pressure and temperature properties. High critical pressure and temperature. If it is so, what is critical temperature or pressure? At this temperature and pressure, liquid refrigerant boils, evaporates to without any absorption of latent heat. Yes, our system is dependent totally on the absorption and release of the latent heat of the refrigerant itself. And if the critical temperature is not that high, at that temperature reach very quickly, and this phase change of the refrigerant will take place within moments without any absorption or release of the heat itself. So that is not visible to us. Our critical temperature should be sufficiently high, or the refrigerant should be sufficiently high. Next, high latent of vaporization. High latent heat of vaporization. Means if we have to have very high latent of vaporization, it will release, refrigerant will release much higher amount of heat, will release much higher, খুব high amount of heat at the moment of evaporation of condensation. This will make the surroundings unnecessarily high. Unnecessarily high. And low specific heat of fluid and high specific heat of vapor. Low specific heat of liquid refrigerant, and high specific heat of specific heat of vapor refrigerant. What happens to here? Much small amount of heat will have, it will make small amount of heat will be absorbed. But high amount of heat will be released of heat will release for same mass flow rate. What happens? Those specific volume of vapor means it has low volume at low volume per kg of refrigerants. So much higher amount of what will happen, much higher amount of refrigerant is required. Next, high thermal conductivity. It should have high thermal capacity. Means it will easily take away the heat from the surroundings in the refrigerator, and it quickly can convert the heat to the surrounding atmosphere in condensation system. It can easily absorb heat from absorb and release from surroundings and release it. Next, non-corrosive nature. Non-corrosive nature. It should not react with the tubes of the tubes carrying tubes of carrying the refrigerant. It should be non-toxic. It should not have any adverse effect on over the human being. No adverse effect of the over the health of the human being. It should be low cost. It should be cheap, easily and available, and regularly available. Generally, special type of refrigerants are required to be available with specific customers against specific order with specific lead time. And it is supposed not to be like this. You can easily purchase it even by giving a phone to your supplier itself. It is easy to liquefy at moderate pressure and temperature. Easy to liquefy at moderate temperature and pressure. It is easy to liquefy at moderate pressure and temperature. Moderate temperature and pressure. It will transfer into liquid in the condenser process itself, and its have the property should be liquefied very easily. Otherwise, even going to the expander, a certain portion of it will remain in the gaseous state, which is then we have to use the condenser in a subcooled area, so that everything will be released there. Every every refrigerant should be converted into liquid before going to the expander itself. But subcool requires more amount of heat released from the surroundings, and it requires more amount of time to release the heat totally to convert to the for conversion. That is not desirable exactly. Next, it's easy of locating leak by order the leakage. In past, leakage was one of the most important problem. Was one of the most important problem problems in RSC system. Refrigerant should have a proper color and should have a proper color which can be rejected can be detected easily. Now, they should have mixed oil well with the oil itself. It should mix well with oil. Means at compression, compressor valve at compressor valve should have lubricants for smooth running of compression, and it should represent should be mixed easily with it. It should have high coefficient of proper performance. High COP and ozone friendly. It should be now the standard compression refrigerant as is refrigerant industry is based on the ideal evaporating temperature is minus 15 degrees centigrade and ideal condensation temperature is plus 30 degrees centigrade. Ideal evaporating temperature for refrigerant should be minus 15 degrees centigrade and condensation temperature should be plus 30 degrees centigrade.